Good morning, everyone. I am Sukanya from BSc Chemistry Honor Final Year. I am making a organic chemistry video for visual impaired student. Chemistry in everyday life. Journal introduction of all the science, chemistry in journal and organic chemistry in particular has played a vital role in improving the quality of human life. Many substances which we use in our daily life are chemical compounds. For example, the material we use for cleanness, such as a soap, detergent, household, beach paste, etc., are also made up of chemical compounds. Similarly, cloth, cotton, wool, silk, trilene, etc., we wear and dye we use to brighten and butterfly them are again made up of chemical compounds. Likewise, the food, carbohydrates, protein, oil, and fat, vitamin, etc. we eat consist of organic compounds. Most of a medicine we use to protect us from disease and elements are all organic compounds. Similarly, explosive fuel, rock pollen, etc., are also made up of chemicals. In nutshell, we can safely say that chemistry has influenced our life so much that we do not even realize that we come across chemicals at every moment, that we ourselves are beautiful chemical creation and all our activities are controlled by chemicals. In the unit, we shall briefly discuss the application of chemistry in three important and interesting areas such as medicine, food material, and cleaning agent. Medicine. Ayurvedic and Unani system of treatment of disease have been used widely in the past, but nowadays these systems are widely replaced by the modern allopathic system. In all this system, drugs used are chemical compounds of natural or synthetic origin. It is here where chemistry has played an important role in providing newer chemicals of synthetic origin which can be used for treatment of disease. Chemical substances of natural or synthetic origin which are used for curing disease and reducing suffering from pain and called medicine or drugs. The branch of a chemistry which deal with the treatment of disease using suitable chemicals is known as chemotherapy. Medicinal chemistry. On the other hand, medicinal chemistry deal with the design and synthesis of drugs or medicine based on an understanding of how this work in our body. What are drugs or medicine? Drugs are chemical substances of low molecular mass. These interact with their macromolecules target carbohydrates, protein, nucleic acid, and lipid to produce a biological response. If the biological response is therapeutic and useful, these chemicals are called medicine and are used for the treatment, diagnosis, and prevention of disease. If, however, a drug is used in dose higher than those recommended by doctor, it acts as potential poison. Difference between the term of drugs and medicine. From chemistry point of view, there is no distinction between the term drugs and medicine. That is, all the drugs are medicine and all medicine are drugs. However, our society and law make a clear cut distinction between these two terms are also a medicine is a chemical substance which cure the disease, is safe to use, has never toxicity and does not cause addiction. In contrast, a drug is a chemical substance which also cure the disease but is habit forming, cause addiction and has a serious side effect. Thus, both penicillin and heroin are medicine because penicillin is an effective antibacterial agent and heroin is a powerful painkiller, but penicillin is called a medicine since it does not have a addictive property, while heroin is called a drug because of its pronounced habit forming and addictive property. Classification of drugs. Drugs may be classified in a number of a different way. Some of these are discussed below. On a basis of a pharmacological effect, as the name suggests, the classification is based upon the pharmacological effect of a drugs. It is more useful for doctor because it provides them the whole range of drugs available for treatment of a particular disease or infection. For example, reducing or kill pain will antiseptic either kill or arrest the growth of microorganism. On a basis of a drug action, the classification is based on action of a drugs on a particular biochemical process. For example, all antihistamine inhibit the action of a histamine which cause inflammation in a body. As discussed later in this unit, there are various ways by which the action of a histamine can be blocked. On basis of a chemical structure, drugs have also classified on a basis of their chemical structure because drugs have common structure feature, often have similar pharmacological activity. For example, all sulfonamide having the common structure feature as given below as most bacteria. Benzene NH2 S double bond oxygen to side NHR on basis of their molecular target. Drugs usually interact with the biomolecules or biological macromolecules such as carbohydrates, protein, nucleic acid, and lipid. These are called target molecules or drugs target. Drugs possessing some common structure feature may have the same mechanism of action of this drug's target. This classification based upon the type of molecule target with which the drugs interact is the most useful classification for the medicinal chemist. How do drugs interact with target? Drug target interaction. We have already discussed in section 16.22 that drugs interact with macromolecules like carbohydrates, protein, nucleic acid, and lipid present in the cell. These macromolecules perform various functions in a body. For example, protein performs survival role in a body. Protein which act as biological catalyst in body are called enzyme. Protein which are critical to communication system in a body are called receptor. Protein which carry polar molecules across the membrane are called carrier protein. Nucleic acid have coded genetic information for the cell wall. Lipid are carbohydrates act as structural material for the cell membrane. However, here we will discuss only the interaction of drugs with enzyme and receptor. Enzyme as drug target. How to enzyme catalyze the reaction? Catalytic action of enzyme. In order to understand the interaction between a drug and an enzyme, it is essential to know how do enzyme catalyze the reaction. In this catalytic activity, enzyme perform the following two major functions. The first function of an enzyme is to hold the substrate molecules for a chemical reaction. The active site of enzyme hold the substrate in a suitable position so that it can be attacked by the reagent effectively. The substrate molecules bind the amino acid residue of a protein present on a active site of a enzyme through a variety of interactions such as hydrogen bonding, dipole-dipole interaction, van der Waals interaction, and ionic bonding. This binding force should be strong enough to hold the substrate long enough so that the enzyme can catalyze the reaction, but weak enough to allow the product to depart after their formation. The second function of a enzyme is to the functional group which will attack the substrate to carry out the chemical reaction. The function is carried out by some other amino acid residue of protein present on the active site of a enzyme. These provide free amino group to attack the substrate and bring about chemical reaction. If the amino acid serine is present nearby the substrate held on the active site, then its OH group is free to act as a nucleophilic in a enzyme catalyzed reaction. The part of a amino acid which lie outside the box act as a nucleophilic in enzyme catalyzed reaction, but the part of a amino acid which is enclosed in the box is involved in formation of a peptide bond in protein molecules. Similarly, the functional groups such as SH of L cysteine, COH of L aspartic acid, phenyl ring of L phenylalanine, and heterocyclic ring of L histidine can participate as nucleophile in enzyme catalysis reaction. How do drugs interact with enzyme? Drug enzyme interaction. Drug which inhibit any of two activities of the enzyme discussed above are called enzyme inhibitor. Enzyme inhibit can block the binding site, thereby preventing the binding of a substrate to the active site and hence inhibiting the catalytic activity of the enzyme. Drugs inhibit the attachment of natural substrate on active site of enzyme in two different ways. Explained below. Drug which compete with natural substrate for their attachment on a active site of enzyme are called competitive inhibitor. Drugs and natural substrate competing for active site. Next, some drugs however do not bind to the active site but bind to the different site of a enzyme which is called allostatic site. The binding of a drugs at the allostatic site change the shape of the active site of enzyme in such a way that the natural substrate cannot recognize it. Such enzymes are called non-competitive inhibitor. If the bond formed between an enzyme and the drugs inhibit is a strong covalent bond which cannot be broken easily, then the enzyme is blocked permanently. The body then degrades the enzyme drugs complex and synthesizes the new enzyme.